students, in this session we are going to see design of logic circuits using sum of product method. Okay, let's see the method, and today we are going to convert a given truth table to its corresponding logic circuit. Conversion of a given truth table to the corresponding logic circuit. Before going into the details of the method, we have to familiarize with the term fundamental product, or in other words, min terms. It is represented using small m. So let's see what is fundamental product. Fundamental product can be defined as the possible product of input variables which gives high output. The possible products of input variables which gives high output. For example, if you have two digital variables A and B, the possible combinations of these two variables are tabulated here. A can be 0 and A can be 1. Similarly, B can be 0 and 1. So let's see the first entry, A equal to 0 and B equal to 0. And the corresponding fundamental product is written as A bar B bar. Why so? Because we know that the output of a logical product is high or 1 if and only if the inputs are 1. Here the inputs are zeros, and we have to invert the input and then take the product. Then only we will get high output. So here A, B will give you output 0. But if you invert it, A bar, it become 1, and B bar, it become 1. So the product A bar B bar will be equal to 1 or high. So the fundamental product corresponding to this first entry 0 0 is A bar B bar. I hope you understand fundamental product, that is the possible product of variables which are leading to a high output. So let's see the second entry, A0 B1. So what we have to do to get the fundamental product? We have to invert A, that then only this become 1. So A bar B is 1, so no need to inversion. So that is the output will be, the fundamental product will be A bar B. What about 1 0? It will be A B bar, and for 1 1 it will be A B. Hope that you are getting me. And for two variables A B, the fundamental products are A B bar, A bar B, and A bar B bar. So 4 fundamental products are there for two variables. Okay, and in the figure you can see that I had given you the logical representation or logic circuit of these fundamental products. We know that the product is given by the AND gate, or for example, if we have to get an output of A bar B bar, what we have to give A bar and B bar as the input. Similarly, I had shown the 4 fundamental products and their logical circuits. Okay, then what will be the case of fundamental products for 3 variables? Imagine 3 variables A, B, C. How many fundamental products will be there? Before discussing that, I am explaining one basic thing. This last slide I had shown you the possible combinations of AB. it will be very easier. Now we have to see possible combinations of A, B, C. How can you write this truth table? It is based on 4, 2, 1 code. That is, the first position is 2 raised to 0 position. This 2 is base of binary number and our binary numbers are 0 and 1. So the first position is 2 raised to 0, that is, it is 1. Second is 2 raised to 1, that is 2, and third is 2 raised to 2, it is 4. So that is 4 to 1 code. You remember this one. And then from first row to last row, what we are writing? 1, 2, 3 up to 7. Okay. So the first one is 0. So all the entries will be 0. Second one is 1. So one position of 1 should be 1. All the others should be 0. 2. Position of 2 should be 1. All the others should be 0. 3 is 2 plus 1, so 2 and 1 should be 1, and then 4 should be 0, that's why 0 0 0 1 1. Similarly 4, that is 4 position should be 1, all the others should be 0. 5, 4 plus 1, so 4 is 1 and 0 and 1. Then 1 1 0 will be 4 plus 2, that is 6, and 1 1 1, 4 plus 2 plus 1. I am telling this code 4, 2, 1. If you are not capable enough to write with high speed, you just remember this code 4, 2, 1 and the combination. So we are starting from 0 and ending at 7. Okay. And this is the way that we have to write the possible combinations of ABC, and this you have to by heart this, and it's very important for our future studies. Okay. And if it is 4 variables, what will happen? Here one more column will be there, and it will be 2 raised to 3 position, that is 8. That time the code will be 8 4 2 1. There that time we have to start from 0 0 0 0 to 1 1 1 1 1. That is, we can write from 0 to 8 4 2 1 is 8 plus 4 12 plus 2 14 plus 1 15. So that is, we have to write from 0 0 0 0 to 1 1 1. That is about 4 variables. So then this is not our discussion point. I just mentioned how we can write these possible combinations only. So remember this 4 to 1 code. Coming back to our discussion of fundamental product. We are discussing fundamental products of 3 variables. Okay. So we had written this possible combinations of ABC. And let's see first 2 entries, then you will get the other entries. Let's see. First entry, all these are 0. How can we convert it to a product which is getting high output? We have to invert all the entries, that is A bar, B bar and C bar. Then only these 3 will become 1 and then the product will be 1. Got the point? What about second? The first 2 are 0. Convert it to 1 means A bar, B bar and then C is okay. C, no need for inversion. Third, what about A bar, B, C bar? Got the point? Similarly, you could write all the fundamental products. I had drawn some of the logical circuits of these fundamental products for familiarization only. No other implications are there for these circuits. You just familiarize what is a fundamental product. Fundamental product is the combination of inputs that are giving high outputs. Combination of inputs that are giving high output, that is output is equal to 1. So here you can see that there are for 3 variables, how many fundamental products are there? 8, that is 2 raised to 3. For 2 variables, how many fundamentals were there? 4, that is 2 raised to 2. Then in general, if there are n variables, how many fundamental products will be there? 2 raised to n fundamental products will be there. So this concept is essential for understanding our sum of product method. Our today's session is all about designing a logic circuit. corresponding to a given truth table. For that, we are using sum of product method, and for understanding that methodology, we have to understand fundamental product. I think you got this point, fundamental product. Okay, so let's see what is a sum of product equation. Any Boolean equation consisting only of product terms. These fundamental product terms are also termed as min terms, is said to be in canonical sum of product form. So what is a sum of product equation? It is a Boolean equation which consists of only fundamental products. So product sum of these products. Okay, let's see how to write sum of product equation of a truth table. Okay, so you are given with a truth table, and I am showing here, this is your truth table. By the way, let's discuss a bit about truth table. Do you know what is a truth table? If you know, it's okay. If you don't know, it's the answer. Truth table is a table which gives you conditions of input and output of a digital circuit. It is a table that gives you information regarding various input conditions and the corresponding outputs of a digital circuit. That is truth table. Okay, so back to our discussion, how to write sum of product equation of a truth table. So every logic circuit has got its own truth table. So different logic circuit have different truth tables. So first of all, we have a truth table. You could see that first 3 entries are 0, fourth one is 1, other is 0, all the others are 1. So you just see all the input conditions. That's why I said you have to by heart how to write from 0, 0, 0 to 1, 1, 1. Then it's very easier. You have to note this in your notebook also, this truth table. 3 steps are there to write a sum of product equation of a truth table. 3 steps are there to write sum of product equation of a truth table. Okay. So now let's start. First step, locate each high output in the truth table. Okay, let's locate. I located all the high outputs and changed it into red color to distinctly see it. Okay, so first step, locate each high output in the truth table. Coming to the second step, write down the corresponding fundamental product. So the first entry, I located the first one for the fourth entry. What will be the fundamental product? This is 0, we have to invert. So A bar, B, C. What about this entry? This will be A, B bar, C. What about this one? A, B, C bar. And this will be ABC. So this is the second step. Write down the corresponding fundamental products of high outputs that we located in the first step. Okay. Then coming to the third step, you have to sum these products. It's very simple. We are entering into the sum of product equation. That is, you got 4 fundamental products here. What you have to do? You have to OR. OR means take the sum, logic sum of the fundamental product. That here you could see the equation as y. That is important. Left hand side should be y equals A bar BC plus AB bar C plus ABC bar plus ABC. This is one of the form of a sum of product equation. The same equation can be written in the another form, that is written here, and this form is known as canonical form, where you could write y equal to a function of input variables are a, b, c is equal to, since it is sum of product, we can show its summation sign, and since it is min terms, we are writing sigma m. On the symbol bracket, we have to write the numbers. So this entry is corresponding to first product is corresponding to which number? 0, 1, 1 is which number? 2 plus 1, 3. And this is corresponding to, second is corresponding to a, b bar, c is corresponding to which number? 4 plus 1 is 5. Next is corresponding to 4 plus 2, which is 6. Next is corresponding to 7. So that numbers are entered in the symbol bracket. So this is the another form of writing sum of product. That form is known as canonical form. So this first one is the standard form and second one is the canonical form. Okay. First one, y is equal to a bar bc plus ab bar c plus abc bar plus abc, and second one is y is equal to a function of a, b, c. All are should be in capital letters, that is equal to sigma m. That is sigma m is sum of min terms. Okay, 3, 5, 6, 7. So my dear students, now we reached into half part of our destination. What we have to do? We have to design a logical circuit. For that, we are given a truth table. Now what we did? We converted the truth table into the corresponding logic equation. It's very, very important. Now you know the logic equation corresponding to this truth table. Okay. This equation is, logic equation is sum of product equation. Okay. So next step what will be that we have to convert this logic equation to logic circuit. So 3 steps are there. First, the given truth table is converting into sum of product equation. Second step, that's logic equation is converting into logic circuit. And it's very, very simple. Our logic equation is this one. Last slide itself I had mentioned this equation. How many products are there? First one, 1, 2, 3, 4. So how many AND gates are required? 4 AND gates. So 4 AND gates are leading to an OR gate. Since there is plus sign, so this will be y will be equal to this. So let's see, first AND gate whose inputs are a bar, b, c. What about second AND gate? A, b bar, c. Third, a, b, c bar. Fourth, a, b, c. So these outputs are giving to an OR circuit, so that we will get the logic sum of all the products. Okay, sum of all the products. So important point, the logic circuit corresponding to sum of product equation will be always AND OR circuit. It will consist of ANDs and an OR gate. Okay, it will be an AND OR circuit. And another thing is, every AND OR circuit is equivalent to NAND circuit. That means you can convert the same circuit to NAND. That is, convert all the AND gates and the OR gate to which gate? NAND gate. So this is again converting all. Instead of AND gates, we are drawing NAND. No other changes are required. Inputs, everything is the same, and the OR gate also replaced by a NAND gate. So sum of product equation can be represented by both AND OR circuit and NAND circuit. You can draw it AND OR circuit and NAND circuit. I think you got the point. So let's summarize today's session. You had seen a method, a new method to convert the truth table to a logic circuit, that is sum of product method, and here you designed the logic circuit starting with truth table, and the truth table will give you an information regarding the input and output conditions of any digital circuit. And first of all, we converted that truth table into equivalent sum of product equation using the 3 steps. My dears, please remember the steps. Locate high outputs, write the corresponding fundamental products, and third step, take the sum of all the product. And then what we had done, what we did, draw the corresponding and or NAND circuit. Hope that you are familiarized with the sum of product equation, and I must thank each and every one of you for your patience listening. Before leaving this session, I have to mention a word regarding truth table again. Truth table is a table will tell you the true conditions of inputs and outputs of any circuit. That means if you try that you had found a sum of product equation corresponding to our truth table. Now you have a truth table and now you have a sum of product equation, and you check whether the sum of product equation is right. What you have to check? You have to check everything. The first entry 0 0 0, what should be y. You had found that y is equal to some equation is there. Put this, instead of a you put 0, instead of b put 0, and instead of c you put 0, whether the conditions, whether the output is reaching. And you can cross check it. No need of cross checking further, but this will be right. If anybody is interested to cross check, you can cross check. Okay, I am not confusing you, I hope. And thank you so much. Thank you.